All right, so I am recording this now. Okay. All right, so for the first one, it says fill in the missing parts. Gary has 4 stamps. He collects 3 stamps every 2 weeks. All right, so that's the verbal part. The algebraic part, I'm going to write this the number of stamps. Okay, he started out with, and I'm going to model this after y is equal to mx plus b, where b is the starting point. And the starting point, he had 4 stamps. So that one's going to be plus 4. Started out with 4 stamps. M is the slope or the rate of change. He collects 3 stamps every 2 weeks. So that's a stamp and a half per week. So I'm going to write that 1.5 t plus 4, where t is the number of weeks. Where t is the number of weeks. Okay. Numerically, we are given a data table, and we were given 0, 2, 6, and then 6 over here. Now, this would be t, and this would be s. So he started out, I can use the equation or just think about it. He started out with 4 stamps. Okay. After 2 weeks, after 2 weeks, he had 3 more, right? According to the verbal, or even according to this algebraic expression, plug in 2 for t, and you end up with 7. All right. After 6 weeks, he collects 3 stamps every 2 weeks. That's 3 intervals. So he would get 6 more. He would get 4 more stamps, or from here, or 13. All right. And then for 6, okay, if you plug in 6 for s and you solve for t, you actually get 4/3. Okay. I wrote 1.3 on the answer sheet. I probably should have left that as 4/3. I should have left that as 4/3. Okay. And then graphically, okay, started out at 4 and he increased from there. So he increased by 1.5. So if we had a grid to go by, I would have a slope here of 1.5. Okay. And that would be the graphical representation of this. All right. All right. Stop me at any time if you have a question. Okay. The next one, I have f of x equals x squared minus 4x, and g of x being 15 minus 4x squared. And what they wanted f of 4 plus g of 3. So f of 4 is 4 squared minus 4 times 4. That's 16 minus 16. That's 0. That's weird. And then g of 3 is 15 minus 4 times 3 squared. 3 squared is 9. 4 times, that's 15 minus 36, or negative 21. So for part A, f of 4 plus g of 3 is negative 21. Negative 21. Okay? Negative 21. For part B, they wanted f of x plus 2. F of x plus 2. All right, so I'm going to plug x plus 2 in for x up here, and I get x plus 2 squared minus 4 times x plus 2. All right, so then that should show up a little bit better on the camera. This is x plus 2 times x plus 2. Well, after I square it. And then distributing that, I get minus 4x minus 8. Okay. I'll try to point that straight down. Maybe that's a little bit better. All right, doing FOIL on this. First, x squared. Outer plus 2x. Inner plus 2x. Last plus 4. Minus 4x minus 8. All right, I have like terms there. And I have like terms there. X squared is all by itself. So I get x squared plus 2x minus 4x equals 0. That goes away. Plus 4 minus 8 gives me x squared minus 4 for an answer. x squared minus 4. All right. X squared minus 4. All right. All right, so that's that one. Next, let's see, we want the equation in point slope form of the line that goes through -3, 4, and 6, -5. All right. Okay, so slope equals y2 minus y1 over x2 minus x1. X1, y1, x2, y2. So y2 is -5 minus y1 over x2 minus x1. That's -9 over +9, or -1. So the slope is -1. Okay, now point slope form is y minus y1 is equal to the slope times x minus x1. Okay. Now, x1 and y1 come from the points. So I could write this as y minus 4 is equal to -1, that was the slope, times x minus x1. And there is an answer. I could also have used, or I could have used the other point, and I could write this as y minus y1 equals the slope times x minus x1. Either of those answers would be correct. You don't have to write both of them, but you would have to write one of those. Either of those would be correct. Okay? All right. If you, sorry, if you solve these for y, that is, if you put it in slope-intercept form, you would end up with the very same equation. Okay. All right. That's that one. Okay, next one. It says it wants the slope is equal to 3, -3 actually. Oh, sorry, angle that up a little bit. Slope is equal to -3, and it contains the point -4, 2. And they want it in slope-intercept form. All right, well, I know the slope is -3. I'm going to use these points to find the b. So 2 is equal to -3 times -4 plus b, which is equal to 12 plus b. That makes b -10. And so my answer then is y is equal to -3x minus 10. That's my answer for that. Okay. Next, we want to factor x cubed plus 13x squared minus 42x. And so first of all, I'm going to pull an x out of there. So that's x times x squared plus 13x, x squared plus 13x minus 42. All right, and then I got to factor this. So let's see, I need factors of, did I do that right? No, it's plus 42x, sorry. Thought I saw something wrong there. Factors of 42 that add to 13, and that's 6 and 7. So I got x times x plus 6 times x plus 7. Okay. And that's our answers for that. All right. Next one. 6n squared minus 19n plus 8. All right, so I get factors of 6. I got 1. Now, however you factor this is the way that I do it. And I factors of 8 that add to a -19. That negative sign indicates that both of these are negative. Okay, so now I need combination that will add to a negative 19. And after fishing around for a while, I found that it would be equal to this. Okay, 3 times negative 1 is negative 3. 2 times negative 8 is negative 16, and those add to negative 19. So that's the combination that I want, that combination right there. Okay. However you do this. So I got 2n, 3n. Okay, and then my 2 is paired with the negative 8. That's the outer. The 3 is paired with the negative 1. That's the inner. And so that's my answer for that. Okay. All right. Okay. Next one, solve by factoring. Okay, 35x squared minus 29x minus 35 is equal to negative 7. All right. So to solve this, I have to set this equal to 0. So I'm going to add 7 to both sides. And I get 35x squared minus 29x minus 28 equals 0. All right, so now I have to factor this thing. 35. I'm going to guess that it's not 1 and 35. It's probably going to be 5 and 7, probably. And then for negative 28, I know I got 2 and 14, 1 and 28. I'm gonna try the ones that are closest together first. So negative 4 and 7, and 4 and negative 7. I'm going to try these first. Okay. And when I do that, I eventually arrive at this combination right here, because 5 times 4 is 20, 7 times negative 7 is negative 49, and that adds to a negative 29. All right, so that's the combination that I want. All right, so I go 5x, 7x. 5 is paired with the 4, so that's an outer, so that's plus 4. 7 is paired with the negative 7, that's an inner, equals 0. However you factor that, you should end up with this. Okay, now we set each of them equal to 0. Add the 7 to both sides, and then divide out the 5. And so I get x is equal to 7 over 5. That's one answer. Over here, subtract the 4, divide out the 7, and I get negative 4 over 7. And that's my other answer. Okay? All right. Questions? Questions? All right, that's that one. For the next number one, for the next part, I want to share the screen because I want to go through this. Oops, where do I have that? I had that. Oh, where did I have that? Get this out of the way. I had that. Where did I had it? I thought. Oh darn it! Now what did I do with it? Oh dear. Okay, hold on a second. I got to get back to. This week. I thought I had it open somewhere, but it'd probably take me longer to find it. So I have, here's a sample final. And I want to scroll down to this. Okay. Identify if the relationship represents a function. All right, now I focus my attention on duplicates. So here's a 0 and there's a 0. I see that negative 13 is going to 0 and 2 is going to 0. But that's okay. It's okay to have 2 inputs go to the same output. That's all right. All right, so this one, number 1 is a function. All right. Number two, now notice number two, -5 goes to 0, 6 goes to 0. Okay, nothing wrong with that. But look down here, -5 goes to 1. So I have -5 going to 0, and I also have -5 going to 1. The same input is going to two different outputs. It's like the same person going to two different rooms. That's not allowed. Okay, so number two is not a function. Number two is not a function because we have the same input going to two different outputs. All right, let's take a look at number three. Let's see here. Oh, 5, -40, 5, and 8. That sets off alarm bells in my head. I have, again, have the same input going to two different outputs. So number three is not a function. Number four, f of 0 is 1, f of 2 is 1. That's okay. You can have two different inputs go to the same output. Two people can go to the same room. I have f of 1 equals 0 here, f of 1 equals 0 there. That's just duplicating that. All right. They're trying to confuse me, but I refuse to be confused. That doesn't matter. So that makes that this is okay. This is a function. Okay. This is a function. The same input goes to one output, or so there's only one output. How can I say this? The same input does not go to two outputs. So number four is a function. Okay. Number five, identify the independent and dependent variable. A person's name depends on their social security number. The dependent variable depends on the independent variable. So that means that the name is the dependent and the social security number is the independent. The dependent variable depends on the independent variable. Okay, number 6 is a little trickier. Distance from the sun determines the name of the planet. Okay, so I'm gonna kind of just say them in. Dependent determines the independent. No, wait a second. It's the other way around. The independent, okay, determines the dependent. Or saying another way, the name depends on the distance. The name depends on the distance. Okay, so that makes the name the dependent variable and the distance from the sun the independent variable. Okay. All right. Okay, I'm going to stop sharing and go through the next one. Determine algebraically whether each function is even, odd, or neither. Wait a second. Is that actually the, is my, oops, oh shoot. Are my pages out of order? Oh, excuse me about this. I can't get out of the recording. I gotta check it a different one. So I just want to make sure I'm going into this. Oh yeah, I thought it was out of order. Okay. So now I want to determine the domain where the functions are increasing or decreasing or constant. Yes, okay. All right. Now, actually, I think I will share the screen for this and get back into that document, and that document being right here. So here, now it's increasing right here, okay? From -2, it's increasing from -2 to a +1, all right? My cursor is not showing up on the screen, probably because I'm recording. But for number 13, the function is increasing from -2 to a +1. So the increasing is going to be there. It is also increasing over from 5 to 6. From 5 to 6. All right. It's decreasing from 1, all right, it's decreasing from 1 to 5. And I know there's two parts to that, but you can kind of include that in the same one. So you can say that it's decreasing from 1 all the way to 5. all right? And then it's constant. It's constant from negative infinity, all the way from negative infinity to -2, all right? And then I would union that with the constant interval of 6 to infinity, okay? And so if I were to write that, I would write it like this, okay? I would write it like this.
Mr. T,
Yes.
why do you not put a bracket for in the constant for the -2 and the 6?
They they want open brackets for everything, okay? Open brackets for everything. Okay? That's what they that's not how I was taught, but as I recall, but that's how they want it. So I'm going to go with what they taught in their video. All right, so open brackets for everything. Okay. Okay. For the second one, I'm going to share my screen again and go through number 14. Okay, and oh yes, you can see my cursor. All right. So for the increasing part, it's going to be increasing on this interval right there, which is -2 to +2. So for increasing, okay, it's going to go from -2 to +2, and that's the only place where it's increasing. It's decreasing for two intervals, -2, negative infinity to -2, and it's also decreasing from 2 to 5. Okay, so I'm going to union that with 2 to 5. And then and for the constant one, it's going to go from 5 up to infinity. So I would write that like this. Okay. All right. Okay. Sharing once again. Now number 17. The domain, okay, for the domain, we're talking about the x values. So I'm going to start on the left, and I'm just going to go until the function has a value, and it's right here, and it's at -5. And notice that it is a solid point. So in interval notation, okay, in interval notation, that will be a closed bracket, -5. And it goes, and it keeps going to -1 where there's an open circle. Okay, so that's going to be a open bracket. Okay, then there's nothing for a while, and then it picks up at 1 again, closed bracket at 1, and it goes to a +5, which is an open interval. Okay, writing that in inequality notation, I would write -5 is less than or equal to x is less than -1, and 1 is less than or equal to x is less than 5. I will show you that like this. Okay. All right. Okay, for the range. We're talking about the y values. Okay. Now coming up from -infinity, all right, it picks up right there. Now it's a little bit hard to know whether that function actually touches the axis or not. We would have to zoom all the way in. Okay. So I will be, if they give you something like this in the final exam, I will be flexible and I will accept either an open bracket or a closed bracket for that. Okay. Now, the function, as I increase, as I get bigger, it never has, there's an open circle there, but there's a closed circle there. So that means it has a value there at y equals 2. It actually has a value there at y equals 2. And it goes all the way up to y equals 4. And again, it it's kind of hard to know whether that actually touches y equals 4 or not. We'd have to zoom all the way in. So I will be flexible there as well. Okay. All right. And then, so the interval notation would be 0 to 4. And then the inequality notation would look like this. Unless if you had open brackets for there, I would accept that, and then these would be just less than signs. Okay. All right. Okay. That's number 17. Now number 18. All right, number 18. There's definitely so talking about the domain. This indicates that it's going from negative infinity, and there's an asymptote at x equals 0, and then it goes to positive infinity. So interval notation for number 18 for the domain would be negative infinity to 0, open bracket, and then union 0 to infinity. So open brackets on everything in there. And for inequality notation, we would just say that x does not equal 0. It exists everywhere except 0. Okay? That would be the domain. And then the range, talking about the y values, okay? The y values, it doesn't exist for negative values of y. It begins at y is greater than 0, okay? So the range, it does not include 0 because that's an asymptote, but it goes from 0 to infinity, okay? And then we're using inequality notation. Y has any value that's greater than 0 because it goes to infinity according to that. So this would be what I would have for that. Okay. All right. All right. Then let's see here. Identify the x values of each discontinuity. Right, if it is removable or not. All right, I have a discontinuity right here. That's x equals -2. It is non-removable, and it is a jump discontinuity. There's another discontinuity at x equals 3. It is a hole, so that means it's removable. That means it's removable. Right? Okay, for number 2, let's see. I have a discontinuity right here at x equals -2. That's a non-removable infinite discontinuity. There's another one right here at x equals -1. That is removable. That's a hole. And then I have another discontinuity right here. Okay, that's at x equals 1, and that's a non-removable jump discontinuity. All right. Any questions so far? All right. Now, limits. Now, limits get a little bit tricky. We got to be careful with this, okay? Now, let's see here. I have this function over here. Okay, that's fine. The limit as x approaches 2, and that little negative sign means it's approaching 2 from the left. So I'm approaching x equals 2. I'm approaching from the negative side. So as I approach x equals 2, the limit is right there, and that's 3. That's a limit of 3. So the answer to that one is 3. All right, letter B, f of 3. F of 3 is right there. 1. 1. So f of 3 is 1. The limit as x approaches 0. Now, as x approaches 0, there's no plus sign or minus sign there. That means that it has to approach the same value from both sides. So x equals 0 is right there. Okay. Approaching it from the negative side gets me to 1. Approaching it from the positive side also gets me to 1. So the limit is 1. Okay, the limit is 1. All right, now this one. X approaches -2 from the positive side. As x approaches, there's x equals -2. As it approaches -2 from the positive side, the limit is right there. The limit is -1 as it approaches it from the positive side. So the answer to that one is -1. F of -2. Well, there is no f of -2. F of -2 does not exist. DNE. Letter F. As x approaches -2 from the negative side. All right, as x approaches -2 from the negative side, it approaches this value, or -2. So the answer to that is -2. Okay, now this one. X approaches -2. There's no sign there. There's no plus sign, there's no minus sign. That means that it has to approach the same value from both sides, and it does not. It was -2 from the negative side. It was -1 from the positive side. So that means this limit does not exist. That limit does not exist. All right, f of 2. F of 2, that's right here. It's 3. F of 2 is 3. That was an easy one. F of 2 is 3. The limit of f of x as x approaches 3 from both sides. As x approaches 3 from both sides, as it approaches 3 from both sides, it approaches the same value. It approaches 4. So the answer for that is 4. Okay? The answer to that is 4. It approaches the same value from both sides. And then finally, the limit as x approaches -4, as x approaches -4 from both sides, well, it goes to there, it goes to there, goes to the same value, and that value is -2. So that is -2. Okay. All right. Questions about that? All right. Okay. Next, it says find and classify the discontinuities of, let's see, f of t equals, different pencil here, 2t squared plus 2t over t cubed minus 11t plus 24t. Find and classify each discontinuity. Okay, I'm going to do a little factoring here. So I'm going to pull a 2t out from the top, and then I get t plus 1. In the bottom, I'm going to pull a t out to get t squared minus, oops, that was 11t squared actually, 11t plus 24. Plus 24. And then I'm going to factor this trinomial. And that's going to end up being t minus 3 and t minus 8. Okay. And so after I factor this, I get 2t times t plus 1. That's the numerator. In the denominator, I get t times t minus 3 and t minus 8. Okay, now the discontinuities are where the function cannot exist, all right? And the function cannot exist if the denominator is 0, okay? So the discontinuities are going to be, to find them, set the denominator equal to 0, okay? Set the denominator equal to 0. Now, so t is equal to 0, or t minus 3 is equal to 0, or t minus 8 is equal to 0. So t is equal to 0, that's 1, and then t is equal to 3, that's another, and t is equal to 8 is another. Okay, now, so those are the discontinuities. Now, we have to classify them. Now, here's the rule for classifying. Go back to the original function. If the factors cancel out, then it's a whole. If they don't cancel out, it's a vertical asymptote. Notice the t's cancel themselves out. Okay, and so this is a whole. T minus 3 does not cancel out. That makes that vertical asymptote.
Mr. T,
Yes,
so you don't go back to the like original function, you go back to the simplified, like after you've like
after you've factored it.
factored it.
Yes,
Okay.
after you factored it, yes. But it is still it's still the function. Oh, okay, I should clarify. Not the original function as given, but after it's factored. Yes, thank you for pointing that out. You do go back to the factored one, okay? And so to find out if they cancel themselves out or not. And then t is equal to 8. It does not, t minus 8 does not cancel out, so it is a vertical asymptote. Okay. All right, now, a word about this, in case you're wondering. You say, why can't I just, if a t is in the top and a t is in the bottom, why can't I just cancel them out? Well, the answer is because 0, you know how you can, if you have a 4 in the numerator and a 4 in the denominator, you can cancel out the 4s. If you have a -2 in the denominator and -2 in the numerator, you can cancel themselves out. No problem at all. But you can't cancel out zeros. 0 over 0 does not cancel out. Okay, so 0 over 0 actually means still undefined. Anything over 0 is undefined, even 0 over 0. Okay, so you cannot, so if you plug in t is equal to 0 here, you get 0 in the numerator, you get 0 in the denominator. They do not cancel out. Okay, so that rule does not apply to zeros. It applies to everything else, but not to 0. So don't cancel out the t's. That's the moral of that story. Leave it in there, and because then it will end up being a discontinuity and a whole. All right. Okay. Next. Identify the domain of each function. All right. First one was root 5x minus 5 over 5. All right, so I see a radical in there. And when I see a radical, that raises a flag for me, because I know the domain is going to be restricted because the whatever's underneath the radical cannot be negative. So that means that 5x minus 5 must be greater than or equal to 0. Has to be greater than or equal to 0. And so then the taking the 5 over, we have 5 dividing out the 5, and we have x is greater than or equal to 1. And that's my domain for this function. All right. Okay. For the other one, number 7, it says v of t is equal to 3t over t times 9t minus 3. Okay, now I know the denominator can't be 0 anymore, and the t's don't cancel out for the same reason that I just talked about. So t cannot be equal to 0. If it did, it would make the denominator 0. So I know it cannot be 0. And I also know that this radical cannot be negative. But there's an added stipulation that it also cannot be 0. Okay, because that would make the denominator 0. So that means that 9t minus 3 has to be positive. It has to be greater than 0. Okay. All right, adding 3 to both sides, I get 9t is greater than 3. Dividing out the 9, I get t is greater than 1/3. T is greater than 1/3. All right, now, I know it can't be equal to 0, but it's not going to be if t is already greater than 1/3. So I do not need to cite that. I do not need to state that, because it's not in the domain anyway. All right. If for some reason this turned out to be t is greater than -1/3, you know, just cause, then I would have to stipulate that t, although t could be greater than, I gotta write that differently. If, you know, just the problem turned out to be different and I had to end up t is greater than negative 1/2, okay? But t is also not equal to 0, I would also have to state that as well. Okay, that's not part of this problem, but if it did, all right, I would have to additionally state that. I don't have to in this particular case. All right. Okay. Let's see. Oh boy. Okay. Transformations. Here we go. Y is equal to 2 times x plus 1 squared minus 5. All right. For this, I know the parent function is a quadratic. I know that. Oops. Sorry. Off camera. Quadratic. It's the quadratic function. The translation is left 1, down 5. Okay. The general, I should write this. The general one is a times bx minus h plus k. In this case, it would be squared. This is a vertical. Okay. The b is a horizontal, stretch or shrink. That is left to right. And if I wrote it minus h, it would be h to the right. And then this would be up a units of k. Okay, so that's the general form. Okay. So that makes this left 1 or down 5. This 2 is going to be a vertical stretch of 2. And there are no reflections because reflections bring in negative signs. You know, negative sign either in front of the 2 or in front of the x. And there are none. So reflections, none. Okay. Next one, y is equal to negative 4 minus x cubed minus 5. All right, I see this inside here, 4 minus x, and I want to rewrite that, okay? I want to rewrite just inside this parentheses as negative x minus 4. Negative x minus 4. All right, that is that. Okay, that's going to help me because now I know that it's the, oh, by the way, it's the cubic function, right? That's the parent function. The translation is actually to the right, 4, which you may have gotten incorrect if you just considered this 4 inside the parenthesis as positive, right? It's actually to the right, 4. Down 5. All right. The scaling, okay, there 1 is out in front of the parenthesis, 1 is out in front of the x. There is no scaling. And then the reflecting, there's a negative outside for there, so I know it reflects about, it takes from up here to down here, so it reflects it across the x-axis. And because there's a negative sign in front of the x, it takes it to the other side of the y-axis. So there's reflecting about both the x and the y axes. So there's reflection about both. Okay. All right. Let's see. Okay, what's next? Next, I start out with y is equal to x cubed. All right. And vertical shift up 4, horizontal shift left 2, reflect about the x-axis. In the interest of time, I won't go through that business that I go through to do this. But what you would get if you want to do it the short way, vertical shift up 4, that's going to put a plus 4 at the end. Horizontal shift left 2, so that x, remember how it was y is equal to a times bx minus h plus k. Okay. This time, if it's a shift to the left 2, that's going to make this plus 2. And then it's reflecting about the x-axis, so that's going to take the positive value and make it negative. So I'm going to put a negative sign under there. And that's the answer for that one. Okay. For the next one, the rational function, horizontal shift right 3. Okay, so that's going to make that denominator an x minus 3. All right, a horizontal shrink of 1/6, so that's backwards, so actually make that a positive 6. And then it's reflecting about the x-axis. Well, once again, I'm just going to take it from above the axis to below the axis, so I'm going to make that a negative. And that's the answer for number 11 on the sheet. Okay. And if I had time, I would certainly test that with points. Okay. All right. And then for the next one, I looked at the function on the graph, and I just saw what it did to the data points. And I saw that for the first one, that is number 13, I had it that the points were taken to the right 4 and up 1. Okay, I also noticed that there was a vertical stretch of 2. All right, and I also noticed that it reflected about the x-axis. From that, I came up with this equation. Y is equal to negative, that's the reflection, 2, that's the vertical stretch, x minus 4, that's taking it to the right, and then up 1. And I also noticed that it was a quadratic function because it was a parabola. Okay, so there. Okay, that was that one. For number 14, first of all, I noticed that it was the square root function. So now I know it had a general form of y is equal to the square root of x. I noticed that it reflected it about the y-axis. It was on the other side of the y-axis. About the y-axis. So that would be the square root of negative x. Then it shifted it down 3. Okay, it took every point and it shifted it down 3. So that means that I just do minus 3 out there. That's my answer for that. Okay. All right. Okay. All right. Next. Stay with me, camera. Next, let's see, where are we? Determine algebraically whether each function is even, odd, or neither. All right, so let me sharpen my pencil here. All right, so y is equal to 1/2 x squared plus 5. All right, so I have to test, this is equal to f of x. I have to test f of negative x. All right, and once again, if it's f of x is equal to f of negative x, then it's even. If f of negative x is equal to negative the original, then it's odd. And if it's neither of those, then it's neither. So f of negative x here would be 1/2 times negative x, square that, add 5. Well, negative x squared is just x squared. So I go 1/2 x squared plus 5. Oh, that's the same as the original. So it's even. Okay, now the second one, y is equal to x squared plus 3x minus 5. And this is equal to f of x. So f of negative x equals negative x squared plus 3 times a negative x minus 5. That's just equal to x squared. That's minus 3x minus 5. Oh, how does that compare to the original? Well, x squared's okay. That's okay, but that isn't. Positive 3x, negative 3x. So it's not even, it's not odd. It's neither. Okay. All right. And then let's see. Let's see now. For these, I'm gonna share the screen. And let's see, where have I? Here. All right. Okay, use the graph to determine the function. Now, if the function reflects about the y-axis, okay. Oh, excuse me, that's wrong. No, that's true. If f of x and f of negative x are the same, if it reflects around the y-axis, then it's an even function because f of x is the same as f of negative x, right? If it reflects about the origin, so that f of x is equal to negative f of negative x, then it's odd. So if I look at this function, it does neither of those things. It doesn't reflect about the y-axis, nor does it reflect around the origin, about the origin. So for number 8 here, that's neither. Okay. For number 11, notice that f of 1 and f of negative 1 are the same. F of 1, f of negative 1. F of 2, f of negative 2. They're the same. F of 3, f of negative 3. That makes it even. So number 11 is an even. And then for number 12, notice that f of 2 is the same as negative f of negative 2. It reflects about the origin. And if it reflects about the origin, that makes it odd. So the answer for number 12 is odd. Okay? Okay. All right. All right. Actually, I'm going to stop here. Okay. And the reason I'm going to stop here is because that's where I stopped in the other class, and I want both recordings to begin and end at the same place. So, and I did not record the previous one. Okay. And so if they want to watch this, then if the other class wants to watch this, then I'm going to allow them to. So I'm going to stop sharing.